I've been whisking this for an hour and they absolutely refuse to mix. Mayonnaise and moisturizer have a secret in common. I discovered it right here today. Look at this jar of farm-pressed sunflower oil and spring water. They hate each other. I can shake them furiously, but they always separate. It's an invisible chemical war. Oil is hydrophobic, meaning it fears water. Water molecules strictly prefer their own kind. So how do we force these stubborn enemies to cooperate in our daily products? I decided to test this at my potting bench. The secret is a peacemaker. Meet the emulsifier. I found this natural one inside a fresh egg from my coop. It's called lecithin. It acts like a microscopic bridge between the oil and water. One end of the lecithin molecule loves water, while the other end loves oil. It grabs both, holding them together in a tight chemical handshake that cannot break. But just adding the egg isn't enough. I learned that the hard way yesterday. You need intense physical energy, what scientists call shear force, to shatter the oil. I whisked this mixture rapidly, breaking the oil into millions of tiny suspended droplets. The lecithin quickly coats each microscopic droplet, trapping it permanently inside the water base. This exact architecture is why heavy cream doesn't separate into butter and water instantly. It's also the exact same engineering used in high-end anti-aging serums for your face. I noticed that this structure behaves a lot like the soil in my garden. Good soil traps moisture in tiny pockets, just like an emulsion traps oil droplets. But there are two different ways to build this microscopic structure on the farm. If you trap oil inside water, you get a light, hydrating lotion or milk. But if you trap water inside oil, you create a rich, protective body butter. Commercial products use thickeners like xanthan gum to lock these tiny droplets in place. It creates a stable matrix, ensuring your favorite sauce doesn't split on the shelf. However, these delicate molecular bonds have a breaking point, which I tested this morning. I left this perfect creamy sauce out in the hot sun by the window. Sudden temperature changes cause the microscopic droplets to collide, merge, and violently break apart. The emulsion collapses. The oil pools on top, and the water sinks right down. Altering the pH by adding too much lemon juice causes the exact same disaster. The acid destroys the electrical charge of our peacemaker, breaking the chemical bridge entirely. Have you ever noticed your salad dressing separating after sitting in the warm fridge? That is the microscopic architecture failing, releasing the trapped oil back into the wild. To fix a broken emulsion, you have to start over with a fresh egg. You slowly whisk the broken sauce into the new emulsifier to rebuild the bridge. It requires patience. You cannot rush the chemistry of nature, no matter how hard. Once you understand this invisible battle, cooking and skincare makes so much more sense. You are essentially a microscopic architect, forcing natural enemies to work together in harmony. Whether it is a rich mayonnaise or a soothing moisturizer, the physics remain identical. It is satisfying to see how universal these simple rules of nature truly are. Everything is connected, from the kitchen table to the greenhouse and the chemistry lab. What everyday system should we investigate next on the farm? Let me know below.